All right, everybody, welcome to Digital Systems 2. We are still on Lab 1, but now we are starting Part 2. And we're going to be using the JK flip-flop, specifically the 7476. And in Multisim, you can look for the 74LS76 chip. And this is a chip that contains two JK flip-flops with set and reset pins. So this is a negative edge trigger device, meaning that data is transferred to the outputs on the high to low transition of the clock pulse. We discussed this in lecture. So in this video, you'll learn things you need to know about this chip in order to use JK flip-flops in your projects, like your senior design project. So one thing to notice is that when the clear and the pre inputs of the 74S76N flip-flop, which is the one you'll be using in Multisim, when they're both tied to a high logic level, these asynchronous inputs are inactive. So what this does is it allows the flip-flop to operate normally based on its synchronous JK and clock input. So that's why they have it this way. So what I'm going to do now is just kind of show you what's on the screen. Oh, I'm actually running this. Let me go and turn it off. Yeah, so I have all my readers and writers and the clock function generator there visible. But I want to run through the wiring real quick. And I'm going to go ahead and zoom in. Or maybe I don't think I have to do that. If you see here, pin 1, um, it's tied to the function generator. If you follow that in there, function generator. And there's my icon there to open up my function generator. What we have is digital input output pin 1, or digital input output 0. That is actually going to be tied to both the the clear and the preset and the clear. And so we're going to want to have these both set on high. If you see down here, that line 0 is set to high. So I kind of have these already set up the way they're supposed to. Let me go ahead and put the inputs for JK down there. So we have digital input output 1, and if you follow that, right, that is going to the J input, which is pin 4. Now I also have the a little image here from the spec sheet, and so if you follow that, pin 4 is the J input. If you follow it into this JK flip-flop, which is what's inside that chip. All right, so let's go to the digital input output 2. You follow that line. I have it going to pin 16, and that's the K input. So if we look at our image of the JK flip-flop, pin 16 is over here on this side of the chip, and that is actually going into the K input. Um, and I put this on there so you can see how to actually physically wire these things on the footprint. The footprint you have here for Multisim, obviously it's not the same thing for an actual chip. Okay, let's continue. We said we had the pin 1 to the clock. We have our J and K input. We have our preset and clear input. Now let's look at our outputs, the Q and the Q naught. So we have pin 15 actually going to the digital input output 8 for our reader, and so that's going to be over here. Just ignore that 9 is lit up there. Nothing's running, so that's just whatever was on the last state. And then we have the pin 14, which is Q naught, and that is tied to pin 9. So pin 15 and 14. So if we go down here to our chip, pin 15 and 14 are right there, our Q and our Q naught, right? So our Q naught is going to pin 14, and the Q is actually going to pin 15. So again, you're going to wire this up on your board. You already know how to open up the Elvis simulator, so I'm not going to do that again. If you don't know how to do that, go back to my first recording on Digital Systems 2, Lab 1, Part 1. I don't know what that was. The screen just went dark and turned back on. Okay, and I'm going to show you a little bit of the truth table so you know what to expect. What you see up here with the preset and the clear, when we can actually set inputs into them, where the preset is low and then the clear is high. Ignore all these. Right now we're tying the preset and the clear together, so we're going to turn this into a toggle, almost like a T flip-flop. Right, so you'll see down here at the truth table where the pre and the clear are both high, right? Both, they're all high. So we're working with these last 4 rows of the operation of this particular JK flip-flop. So just focus on the last 4 rows down here. And again, there's our simulated clock pulse, just a little bit of picture. What it's saying up here is, like, when you have these set, the high and low, the clock doesn't matter. Neither does a JK matter, because it's the pre and the clear that's actually setting the output. We're just going to look at the operation of the JK. So we have a clock, and the clock is just to show us when this thing is going to transition, and ours is negative edge, so it's going to be transferring from the high to low. All right, so we've already set this hardwired to high. All we're going to do now is just adjust the J and the K inputs, and we want to make sure that they actually match the outputs of the predicted operation of this JK flip-flop. Okay, so what I want to do is focus on the outputs. Oh, one more thing. I want to make sure that I tell you which pin is what. You can probably follow it on your own, but just so I can make sure I lay this out there for you. So the J, right, we said the J, if we follow it, that is going to DEI1. So this one over here on our writer, that actually is the control for the J input. And if we follow the K input, right, K is going to pin 16 there, but it's coming from DEIO2. So 2 is our K input. So this is J, this is K. So we're only working on these two. This pin 0 is the one that we're using to tie the pre and the clear, the preset and the clear together. Sorry, the set and the preset. Again, the set and the preset, or the preset and the clear. Okay, so we're working with pins 1 and 2, and that's all we're going to be changing to match what we have here as our J and K inputs. And what else? The outputs, again, we are going to be reading them on pins 8 and 9. And so we follow pin 8, digital input output 8, which is set up for our reader. Right, we follow that back. That's pin 15. Again, don't worry too much about this. We just want to worry that this is the 8th point on the reader. So that's going to be associated with 8 right over here. Right, so Q is 8 and Q naught is 9. Right now I have Q naught high. I turned off the simulation. That was the last thing that was running when I turned off the simulation. So, but I'm going to start it all over. We have everything for high and everything's on low. So we have this condition right here. And we're going to go ahead and run it and run through the different combinations. And you have to give this a second. It takes a second or two for everything to adjust. So there you notice that the digital reader just turned on. We have 8 that's lit up. And notice over here on our writer, we have DEIO 0 lit up. That's fine. That means that I have the pin 2 and pin 3 set to high. And we can just look at the asynchronous nature of the 74 LS76. Okay, and the first one is low, low, right? Low, low, and that's just going to give us Q and Q naught. This is sort of like an invalid state. We don't have to worry about that. I just want to focus on the next two when we set J to high and K to low. So again, setting J to the high, we said J was pin 1. I just want to double check that. That's pin 1. So I'm going to hit set that to high and keep K low. So do this. Oops. I was going to click on there somewhere. So now we notice that J is high. And I'm here, I'm looking at 1, 2, 3. If you can see the mouse, right? Hopefully the mouse, you can follow it. Right. J is high. K I left it low. So we should be seeing Q high and Q not low. So Q is associated with pin 8 and on the reader, and Q naught is associated with pin 9 on the reader. So if I go up here, 8 is lit, if you can see that, and 9 is off. Now let's go ahead and change the the inputs to the J and K. So I'm going to change J to 0, and I'm going to change K to high, right there. And now I'm on this condition here, this last to the bottom line. L, which is J, which is the low, K is now high. I should be seeing Q go to low, meaning so our little light up there will turn off, and our Q naught will be high, so make sure that is the case. I mean, if you're looking at the video and looking at the right-hand corner, you probably already saw it before I did. I was just kind of pointing down here at the table. Yeah, and so that happens. So this is what you're going to be doing for these part 2 of this first lab for digital systems 2. Now this is only steps 3 and 4. Okay, the next step I'm going to use a different chip, and it's still part 2. And so I'm going to be putting an inverter in there. And what I want to do is I'll go over a few more things. All right, so notice that we have the clock tied to the function generator. I probably should have described this at the beginning of the video. And so you see my circuit is right here. They're asking us for a 5-volt peak to peak at 2.5 volt offset so that we and our rectangular waveform selected. And so what this means is instead of going, if I have 5 volts peak to peak, what that's going to do is it's going to go 2.5 up and 2.5 down to give me a full 5-volt peak to peak as it oscillates above the zero baseline. But if I offset it with a 2.5 volt, that means that the baseline is at zero. Basically, I shifted the waveform up, and so now I have zero all the way up to the 5 volts, back down to the 0 volts, and that's all I've done. That's what it wants you to do for the setup of the function generator. Just leave it like that. And again, the writer and the reader will be, uh, you know, correlated to how you wire these things up. That's it. Hopefully, I've explained this part, which is parts 3 and 4 of your Lab 1 Part 2. I'm going to do another short video starting off with part 5 and 6. And then there's a assignment that you do on your own for this lab. And I'll let you do that on your own. So I'll see you on the next video where we use the 7404. And that is it's just a NOT gate. And we are going to put the NOT gate to the input of, oh, we're using a whole different chip as well, the 7404. Anyway, I'll see you on part 4 and 5 of the video where we cover the second part of Lab 1, Part 2.